Hello, hi everybody. How nice of you to join. Many people, nice. Yeah, so my name is Erik. I'm a software engineer here at bol.com, and I'm here to talk about quality of code, actually how to improve the quality of your code, and how that might help you to grow from a junior engineer to a medior software engineer, or from medior to senior software engineer. Now I know, of course, that the code that you produce is only one aspect of being a software engineer, and there's many aspects to it. But I do believe that improving the quality of the code that you produce will help you be a more skilled software engineer, and as such, bring you further in your career as a software engineer. So, who here likes to build beautiful code, nice and shiny, and it's performant, and it does all the things that you want? Yes, nice, cool. And who's a medior software engineer? Nice. Who's a senior software engineer? Cool. And who's a junior software engineer? Nice, everybody. All the rest are expert software engineers, apparently. So what we're going to talk about here, the format I'm going to use is to look at some common pitfalls, common mistakes that we see junior developers or any developer make along the way. And yeah, in format of like do's and don'ts with lots of examples, quite practical, what you can do to improve the quality of your code. I will be talking about 8 things about code and 7 things more about the general approach of problem solving and such. Please note that these are, you should see them as general guidelines. Some of these might even be opinionated, although I do believe that these are general, that there's general consensus that these are actually good ideas. And also please note that there will always be exceptions. So these are, you should always use common sense. There will always be the exceptions where these guidelines don't apply. Lastly, I'm a backend developer myself, so I made this presentation also with backend in mind, but lots of these things also apply to front-end software development. All the examples are in Java, but it could have been any language, basically. All right, so let's get to it. Adding code comes at a cost. If we add code, we come at the cost, and that is maintenance. The code that you add will be read many times, will be changed and refactored many times. It will be deleted maybe even at a certain point. The code that we add right now is the potential legacy code of the future. So if we add less code, we have less code to maintain. So that's a win. So if we can avoid adding code, then that's a win for us. So pretty obvious, don't write code for something you don't need yet. But let me give you an example. Future features, so features that you think will be there in the future, but actually they might never come. To give a practical example, suppose PO, the product owner, comes to us and asks, please build a product entity with an ID and a description and a price. Okay, well, easy, right? So as a software engineer, we build this code, where we build this nice class with the ID, description, and price, but we add a little bit extra, the created date time and the removed date time, because maybe the software engineer had some future features in mind about this product being removed at a certain point, and then we can log stuff about when that happens. Well, I'd argue that this is not being asked right now. This is a future requirement. And if we don't have to add it yet, then maybe it's a good idea to not add it at this point at all. We can always add it in the future. But if we not add it right now, it's less code, less maintenance. Another example, scenarios that should never happen. Scenarios that your system, that you chose not to support in your system. We come across them all the time. And here we have another chance to not add code. So my point would be to spend as little code as possible on those scenarios that should never happen in your system. Let's look at an example. Suppose the assumption in our system is that the customer should always exist based on some customer ID. And we have to write some code that takes a customer ID, and we have to find in the customer repository that customer. Well, we can write the code above, and what it does is call the customer repository, find, and in 2 lines of code, we have returned the customer, right? Short but sweet. I could also have written the code below. What we see here is a custom exception class, customer not found. I am going to check if the customer is maybe not there. Then I'm going to log some stuff. I'm going to have even a comment in there, and I'm throwing my custom exception now to say the customer has not been found. Well, that's a lot of code for something that basically should never happen, and maybe will never happen. So again, we have the opportunity to not add that code, make the code more concise, more compact, make the code about the things that really matter and not about things that don't matter, more concise. Nice. I really believe that code should be predictable. Code should not contain any surprises. It should not be confusing. Predictable in the sense that if you only look at a part of the code, you can already understand about what it's doing or what's going on there. If, on the other hand, our code contains surprises, that will probably lead to bugs or could lead to bugs. So if you have a method and it appears to be doing something, but actually it's doing something surprising halfway, and I don't know about that, and I use that method, then it might cause a bug in my system because I didn't know about that surprise, right? So something that we should avoid. For example, a method. Well, it should basically just do what it appears to do, right? Common sense. And in the case of a method, we can do that by looking at its signature, and the method should do nothing more. An example. Let's look at this method here on top. We see a find method that takes a string called name and returns an optional person. Well, just by looking at this signature, what does it seem to be doing? Well, it's pretty straightforward. It takes a name, it's going to find based on this name, and we can see from the return type that probably if the person with that name was not found, it will return optional.empty, right? And if the person was found, it will return that person. We could even conclude that the name might be unique because it's never returning multiple persons. It will always return just one. So these are all conclusions that we can take just by looking at the signature from this method. Now, if that's actually what this method is doing and that's what it should be doing, then this is very predictable. And that's good. It helps for maintenance and understanding. However, if we look at the second example, here we have a method that parses some string, protobuf string, and it returns an offset datetime. Well, okay, fine. But halfway this method, it's using a time zone, Europe, Amsterdam, to create this offset datetime. But one cannot see that from the signature of this method. So it's a surprise. It might cause bugs by the software engineer, the system that's using this method. We don't want that. We want nice, clean code, right? Similarly, classes. A class should handle what it appears to handle by looking at its name. Again, simple example. Suppose you have a service called file upload service. What does it appear to do? Well, uploading files, basically, right? If it does anything more or less, or it doesn't upload files at all, then we should have given it a different name. Sometimes your code will contain assumptions. Think like business rules. And I'd argue that it's important and helpful for the quality of your code to make those assumptions, those business rules, explicit in your code. For example, suppose we have an order, and an order contains multiple lines, and all those lines refer to the same customer, right? Makes sense. So this is our business rule. Then by making this business rule explicit in your code, it will help for understanding. It will help the future developer, the future you, new people in your team, like, hey, what's going on there? Well, apparently there is this business rule looking at the code because it's explicitly there. So, same business rule, all order lines refer to the same customer. How do we make it explicit? Well, what I should not do is this. Here, halfway, some code somewhere, it just says, well, I'm just going to take the first line, because all lines have the same customer, refer to the same customer anyway. Then I take the line, and then I take the customer ID from that. Well, I'll just add a little bit of comment saying that this is the business rule that I'm applying here. We can do better. For example, we could add a method on the order that validates this business rule by looking at all the lines in the order and then checking that really all the customer IDs of these lines are all equal, and then return that result. And if it turns out that the assumption is invalid, it will throw an exception. This is reusable, and it's not error-prone. In the first example, if it turns out that the second line really had a different customer ID, we would have a problem. But here, this is checked, so it's safe. So by making this assumption explicit, it's nice that you have your business rule ready there in code to be used. Cool. Number 5. Simple code is easier to maintain than complex code. Try to keep it simple. Yes, of course. Sounds simple, right? I have learned along the years that optimization is a subject that tends to make things complex. So, yeah. But sometimes there's no need to optimize. So, for example, if in your system the performance requirements are already met, then there's really no need to optimize, right? So, point is, I'd say we should prefer simple and fast enough over complex and super fast. And of course, we can always optimize later. If it turns out that the performance requirements change or your load increases very much, you can always optimize later. But by avoiding the complexity, we'll keep our code easier to maintain, easier to understand. Does anybody know who this is on the picture? Yes, it's Donald Knuth. Do you also know why I put it in there? Root of all evil, exactly, yes. The premature optimization is the root of all evil. This is my variation of this quote. So, an example. Suppose you're asked to build something to process 1,000 orders. Well, and first you think, well, I can process them one by one, and actually it turns out that this is fast enough. But you could also argue, well, why don't we do them in batches of 100, because that's like super fast. Okay, but what if the 50th order fails in this batch of 100? What are we going to do then with the first 49 orders? And what are we going to do with the remaining orders? Of course, you can solve this, but the point is, by adding these batched processing, you might be adding more complexity to your solution. And if that's not necessary, then it might be a good idea to opt for the more simple solution. Right? Does that make sense? To use the words of John Woods that I like, always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. Well, if that's what you have in mind, you will make sure that you have high quality of code. Right. We already saw that if you want to build predictable code, that names matter a lot. So names are important, because good names, yes, they make your code predictable. I would also argue that it's better to use a good name than to rely to comments. So if you can see these two examples, in the first we see that we are using the name of the variable quantity requested to reflect what it's holding. We could have also done it with an integer q and then add a little comment saying this is the quantity requested. But actually comments, they age more quickly. We tend to alter the code, but the comments I'll do that later. So they stay around. It's better to use really the code because it will keep more up to date. However, there's a catch, at least I believe. you should not make your names too long, because at least for me personally, I stop reading at a certain point. I can only read so many characters of a method name or a variable name, and then I just basically stop reading. So in this example, I've written down a customer order expected delivery date mutation type. Yeah, that's so long, probably it's not going to work. So you have to make a balance a little bit, like find names that are proper but not too long. Yes, as mentioned, comments, they tend to age quickly. So it's better to use the code itself to describe what the code is doing than to use comments for that. And that's something called self-documenting code. So the code documents itself. And we can use variable and method names for that to our advantage, as we've seen before. Now I'd like to stress that it's really important and that you can use the terms from your domain in here. So when you choose those names, fall back on the terms that you're using in your system and that you're talking about anyway. This is called the ubiquitous language, to use a difficult word in your domain. So use those same words in your code. An example. A special order expires when it's 1 month old. A normal order expires when it's 1 week old, and we are asked to delete all expired orders, right? Okay, so this is our business rules or requirements. Now I could write this code. So what do we see here? It says if is expired the order, then we'll delete it. Okay, cool. We have a little method that determines if it's expired, and it says if it's special, then return is older than 1 month. If it's not special, then return is older than 1 week. Okay, and then I have a little helper method saying to determine if it's older than a certain period of time. Now, what I really like about this code is that it is quite close to the sentence that I've written above. It even uses some of the words that are written above. So the word expire, it's in there. The word old is in there. The word special, of course, is also in there. So hopefully, when somebody who doesn't know this code reads this code, they will be like, okay, well, this must be the business rule then, right? On the other hand, I could have also written this code, and it's doing the same thing, I hope. It's more error-prone because of its complexity. But this code doesn't contain the words expire or old in the code. Only by relying on comments, I'm explaining in comments the business rules here, but it's not in the code. So I would definitely say, let's go for the first one, right? Sometimes also a functional programming style can help you to write self-documenting code, rather than imperative programming style and using state. The Java Streams API, for example, is an example of a functional programming style in Java, and you can use that to your advantage. Okay, so suppose we have a student class, and it contains an age and an IQ, and our target, our assignment is to find the average IQ of students per age. All right, well, this is something where really the Java Streams API helps us a lot, because with these couple of lines of code, I am taking a list of students here in my method. Then I'm going to say, make a stream and do a grouping by age, and then take the averaging int of the IQ. Well, short but sweet, and it's doing exactly what we're being asked to build, right? Again, we see the word average in the code, which was also in the requirements, so that's nice. Well, I could have also written this code, which is not using the Streams API, and it's imperative style, for loops, if blocks, and lots of state. I have 3 hash maps in there, and the point is, if you look at this code, it's very hard to see what's going on here. In fact, only the name of the method, get average IQ per age, kind of is a hint about what's going on, but it's very difficult to really understand what's going on. So again, here we have a chance to use more self-documenting code over not so self-documenting code. Right, number 2. Expose as little as possible and prefer private over public. It's good practice to defend your code from outside changes, as to say, keep the public service of your code small. And you can easily do that by preferring private methods over public methods and by preferring private nested classes and enums over public classes and enums. Why? First of all, it helps to understand your code. If you have a class and it contains some public methods and a bunch of private methods, then you know only the public ones are being used by the outside. So it helps to understand what is this class really about by looking at these public methods only. Also, it helps a lot when you're going to refactor your code, because all those private methods, you know that they're not being used outside of your class, so you can easily refactor them as you wish. That's going to help you. Right, number 1. Use comments wisely. Okay, as I already mentioned, comments, they tend to age quickly, so we should better use comments only when they really add some value to our code, right? So what do? We don't write useless codes. Duh, okay. But we see it all the time. We see, if you would check your code, I bet it's there. And let's, for example, look at these 2 lines. First, we see a method which takes a name, returns a customer, and the comments say, finds a customer by name. Yes, it's not like it's really hurtful right now, because the code might change and then the comments remain, but it's also not helping, because anybody can see from the signature of this method what it's doing. Same, we see sometimes these comments halfway a method somewhere. In this example, I wrote, process all lines, while everybody can see from this line of code that it's going to process all the lines. So really, it's not necessary. You might as well just leave it out. Save yourself some time. So what should we focus our comments then on, if we not for this? Well, on the more important things. For example, things that don't change so quickly. These are typically things in your domain, like business rules, domain objects, business objects and services. Those are the types of things that are really much more worthy of comments. And then you can describe the responsibility of behavior, for example. In this case, I wrote down, suppose we have a cancellation feedback service, okay? And there's a comment saying it processes cancellation feedback from the warehouse, resulting in order cancellations for the customer. Okay, well, that is helps us a little bit to understand what the responsibility and also helps to limit the responsibility of this service. And all these things help to improve the quality of your code. Lastly, we talked about we don't want any surprises, so we should avoid surprises. And we can use our comments also there. So in the example of the parsing of the string resulting in a date time where this time zone was used, that's really somewhere we can use a comment saying like, hey, be aware, the time zone Amsterdam is being used in this method, if you can't fix it in another way. All right. Next to all these things about code, I want to tell you something about the approach, how you do problem solving, how you can also grow as a software engineer in that way. Suppose you're in a meeting or you're talking to a fellow colleague and he mentions X and you think, I've never heard of this. So you might be talking to somebody, they are talking about eventual consistency or Kotlin coroutines and you think, what? I've never heard of that. What is that? I advise you to make a mental note of it and then do a little bit of research later. Just to quickly Google it, like, hey, what is this? What are these Kotlin coroutines? And then the next time you have a meeting, now you know what it's about. And that's much better than keeping to not knowing and thinking, oh, I have to look that up. So it helps you. As a software engineer, it's tempting to start coding immediately after you have solved a problem or if you've solved an issue. But sometimes we should not start coding immediately, but really solve the problem and to verify your solution. Did you think about all the corner cases? Did you test that your solution actually works by taking a real example? If you do that, that will save you a lot of time, because sometimes you didn't think about all the corner cases in the beginning, and you started coding too quickly. This one I really like a lot. Use the whiteboard. We use the whiteboard a lot in our team, and we use it to draw and describe the solutions that we build. I really believe that visualizing helps you to come to the right conclusion, the right solution. So we draw a lot of diagrams, we write it down, and it helps us to verify and find problems. So, for example, this picture right here, I took it yesterday, and it's from a whiteboard. It's right behind my desk, and our fellow YP, young professional in my team, he made this diagram, and I think it's really cool that he's applying this. He's just, when he's working on a story, he's drawing these diagrams, and it really helps also for other teammates to know, hey, what are you working on? Did you think about this? Did you think about that? Use that to your advantage. It's also helpful to consider multiple solutions, because if you solve a problem, the first solution that comes to mind might actually not be the best solution. By thinking of other solutions as well, you can write down some pros and cons and then make a wise decision about what is the best. Right, almost getting there. Read books. If you keep expanding your knowledge, read the classic books about clean code, about functional programming, effective Java. It's a tough field for us. It keeps changing all the time, so you have to keep investing time on this. Number 2, ask for help. It's okay to ask for help. We are all stuck sometimes or unsure, and we like to help each other out. I would even argue that Bol.com employees are selected for being communicative and social and open, so nobody minds to answer your question. And if that helps you to get unstuck within 1 minute, that will save you a lot of time and be more productive. Finally, learn from your mistakes. We all make mistakes. Everybody does that all the time. But we have an opportunity to learn from them and grow. And if we do that, and if you do all this, then I'm sure you will make that promotion in no time, getting to the next level. I will finish with a quote. Any fool can write code that a computer can understand, but only good programmers can write code that humans can understand. Thank you very much.
All right, I think we got time for one question, so...
Okay.
Oh, sorry.
A bit of a pressure to be the one and only question, but... So you work on a team. How fussy are you in your team about all these rules, let's say, these clean code practices?
That's a good question. I'm pretty fuzzy about it. I do try to ask for feedback, like, am I not too fuzzy about it? I guess it just depends on your team, how fuzzy you want to be about it. But it should be about the core quality and not about tabs and spaces and things like that. But like proper naming, there are some... for example, some room, like, are we going to be really strict on it or not? But I would advise you to start quite strict, and then, because if it becomes an automatism, it doesn't take you more time.
Thank you.
No problem.
All right, thank you very much, Erik. Please give him one more warm applause.
Thank you.